In this example, we're going to explore slope as a rate of change. We'll do so by writing two pieces of data as two ordered pairs. We'll then calculate the slope of a line passing through those 2 points and interpret the meaning of this slope in the context of the model. So to start, we're told that water is draining out of a bathtub. When it starts draining, it contains 50 gallons of water. After it has been draining for 8 minutes, it's empty. So these last two sentences give us two ordered pairs that we can write in the form number of minutes of draining, comma, gallons of water. And so the first thing we're going to do is state those two ordered pairs. So looking at this first one, we're told when it starts draining. Now, when we think about measuring time from when we start, we're looking at how many minutes has it been draining, and the answer there is 0. So when it starts draining, the amount of time that it's been draining so far is 0 minutes. So the number of minutes for this first data point is going to be 0, and the number of gallons of water is going to be 50. Looking at our second data point, we're told after it has been draining for 8 minutes, it's empty. Now empty is another thing we want to look at. Empty is going to tell us that there are 0 gallons of water, and that occurs after 8 minutes. So our second data point is going to be 8, 0, because when it has been draining for 8 minutes, it contains 0 gallons of water. Next, we're going to calculate the slope of a line passing through those two ordered pairs. So again, our formula for slope, we can write m equals y2 minus y1 over x2 minus x1. And that's going to tell us the change in our outputs relative to the change in our inputs. So for these points, we'll use 8, 0 as the second data point and 0, 50 as the first. So that second y value is 0 and the first y value is 50. So in the numerator we'll have 0 minus 50. And in the denominator, our second x value is 8 and our first x value is 0. So I'll have 8 minus 0. That'll then simplify to negative 50 over 8, which if I want to approximate, I can put into a calculator, or I could simplify it by hand. I'll put this into a calculator real quick. So taking negative 50, noting that this calculator uses allows the subtraction sign to also be used as a negative sign. So I have negative 50 divided by 8, and that's going to give me negative 6.25. So coming back, I got negative 6.25. And looking at the units on that slope, in the numerator, I had gallons. So I'll have gallons over, and in the denominator, I had minutes. So gallons over minutes. And if I were to write that in a sentence, I would generally write it using the word per. So I'm going to state that I could also write that as gallons per minute. Now looking at this negative slope, the last thing we'll summarize is what that negative slope indicates. But thinking of writing a sentence explaining the meaning of this slope in context, we had a slope of negative 6.25, and our units were gallons per minute. So each minute, the number of gallons is decreasing by 6.25. And we'll use on average, since we calculated that with just two data points. So on average, the tub drained at a rate of 6.25 gallons per minute. And again, I used 6.25. This drained is telling me that it's going down. And the last thing we'll do is summarize what that negative slope indicates. It indicates that the amount of water is decreasing over time. So it's how much is draining, the amount of water is decreasing. So the negative slope indicates that the amount of water decreases in the tub decreases over time. Again, negative slope indicating that it decreases over time. Our interpretation using 6.25 gallons per minute in a word, such as drained in this case, indicating that it's decreasing.